Hello, good morning. So this is Reshma. So going to discuss another interesting topic in design and analysis of algorithms, that is graph coloring using backtracking. So now let's see what is graph coloring problem. So graph coloring is a special case of graph labeling. So that is, here we are assigning the colors to the elements of the graph with some constraints. So then what are the constraints here? That is, now here while coloring the vertices of the graph, we have to color such that no two adjacent vertices have same color, and this type of coloring is referred to as here vertex coloring. So now if we use this graph coloring concept, then we can solve different type of problems related to graph coloring. So first type of problem is M colorability decision problem. Means here they will be given a graph and M colors, and we need to discover, is it possible to color the given graph properly using only these M colors. Properly coloring means we have to color such that no two adjacent vertices share common color. So now second type of problem is M colorability optimization problem. So here they will be just given a graph, and we need to find what is the minimum number of colors required to color this graph properly, and that minimum number of colors is referred to as a chromatic number. So now based on these graph coloring problem types, so we will solve some problems. So now if we consider the first problem, this is based on our first problem type. So now here they have given a graph which contains 5 vertices and some edges, and 3 colors are given. So now we need to color these vertices of the graph using only these 3 colors. So let's see, is it possible to color or not. So now I will start with the first vertex. This is the first vertex. So let's color this vertex with blue color. So now to color the second vertex, we need to check, is this adjacent to first vertex? Yes, this is adjacent to this vertex. So I can't use the same blue color. I should use some other color. So that I will use here red color. So now to label this third vertex, I need to compare with first two vertices. Is this is adjacent to blue and adjacent to red, so I can't use these two colors. I have to go for the next color, so I will use here green. So now once I will come for this vertex, this is adjacent only to green, so I can use either red or blue color. So I will use here blue color. So then now if I go for this vertex is adjacent to this blue vertex, this red vertex, so I can make use of this green. Yeah, so now I have colored all vertices of the graph properly, so without affecting the condition of having same colors for the adjacent vertices, and here we have used only 3 colors. So you can say yes, it is possible to color the given graph properly using only the given 3 colors. So this is one method to solve the problem. In the second method, there will be given just a graph. We need to find what is the minimum number of colors required to color this graph properly. That is, we need to find what is the chromatic number for coloring this graph. So now again for this, I will start with the first node. I have labeled this with blue. Then if you go for this vertex adjacent to that blue vertex, so use some other color red. If I go for this vertex, it is adjacent to blue and red, so give some other color. Now if I go for this vertex, it is adjacent to only green, so use either red or blue. I have used here red. Now if I go for this vertex, it is adjacent to blue and adjacent to red, so I can use here green color. Now if I go for this vertex, see here, this is adjacent to blue vertex, this is adjacent to green node, this is also adjacent to red, so I can't use any of these 3 color. I have to go for the new color. So let I have used here yellow color. So now to color this graph properly, how many colors I have used? We have used 4 colors. So you can say the chromatic number is 4. That is, we need minimum of 4 colors to properly color the given graph. So this is second type of problem. So now we'll see what are the applications of using graph coloring. So this graph coloring can be used in coloring the maps. You might have seen the maps which are having different colors, and how that. So for coloring the map, we have taken the help of this graph coloring. So while coloring the map, what we have to do, we have to color the regions such that the regions which share the border should be colored with different color. So they should not have the same color if they are sharing the border. So if the map contains many regions, then finding the borders which share two different regions is very difficult. That can be easily solved with the help of the graph coloring. Then the steps are here. Just replace the regions of the map with vertices and the common border between the regions as edge between the vertices. Then color adjacent vertices with different color as we have seen in the previous examples. Then once we get the colors for the vertices, we can add those colors to the respective regions and the map will be colored accordingly or properly. So now see one example. So assume that this is a map which contains 1, 2, 3, 4, total 8 regions are there. So now I need to color this map. How to color? First, what are the steps here? First I need to replace regions by vertices and the regions sharing the common border by the edge between the vertices. So for example here, so 8 regions, here I have 8 vertices. So now to write the edges, so we need to check the common border. If I take region 1 here, what are the common borders? It is sharing the border with vertex region 2, region 3 and region 8. So I need to draw the edge from 1 to 2, 1 to 3 and 1 to 8. So if I go for region 2, it is sharing border with 1, 7 and 4. So 2 is sharing with 1, then 4, 7. Similarly, if we randomly will take, for example, if we go for region 7 is sharing common border with 8, 2 and 6. So here vertex 8 is sharing border with, so vertex 7 is sharing border with 7 with 8, see 7 with 8, 7 with 2, okay, 7 with 6. Similarly, if I take 4, it is sharing border with 2, 3, 5 and 6. So for example, 4 it is sharing with 2, 3, 5 and 6. So like this we need to replace regions of the map with vertices and the common borders with the edges between the vertices. So now by using the previous technique, we have to label the vertices so that no adjacent vertex is having the same color. Like one is having blue, two adjacent to this it is red I have given. Again if I go for 7, it is for now if I go for 4, it is adjacent to 2. So I have given some other color. So like this, so whatever the method we have used for vertex coloring in previous two examples, using those techniques here I have colored this graph. After coloring the graph, whatever the vertex colors, color the respective regions with that color. For example, here vertex 1 is having blue color, region 1 should be blue. Vertex 6 is red, region 6 red. Vertex 5 green, region 5 green. Like this, we color the respective regions with respect to the color of the vertices which we have considered. So now if I see this map is properly colored so that we can easily identify the different regions without any confusion. So this is one of the very best or good example application of graph coloring. So now, so the next type of problem is, so now we need to solve such problems, graph coloring problems using different techniques. Here we are using a backtracking technique. So now in backtracking, any problem can be solved by the construction of a state space tree. So now here I will try to solve. So now apply graph coloring or color this graph properly using state space tree. So and here they have given 3 colors. With 3 colors I have to color this graph using, and we need to construct a state space tree. So now if I see this graph state space tree, so as we know root should be the starting point. Then there are four nodes or vertices are there in the graph, so I have to write four levels here. This is for node 1, node 2, node 3 and node 4. Then for the first node there are three possibilities. Either I can use the first color, red, second color or third color. Similarly, if I go for the second node, for the first node if I have used the first color, for second node I have to use second or third color. Similarly, like this we have to use different colors, and that state space tree has been constructed. So now I will show how the step by step way of selecting the colors for the construction of this state space tree. So now for example here start with the root node, the starting point. Then there are three colors, so first node can be colored with three colors, that is three ways. So now here the first node can be either red, yellow or green. Now if the first node is colored with red, then second node should be either yellow or green. Now if the first node is yellow, then second node should be either red or green. Similarly, if the first node is green, second node should be either red or yellow. So like these two nodes are labeled. Now to label the third node, for example here red, yellow, then next node should be either red or green. Similarly, if it is red, no, first node is red, second node is green, third node should be either red or yellow. Similarly here, first node yellow, second node red, next it should be green, yellow or green. Again fourth node yellow, green, red, yellow. So like this, similarly these two can be colored. So like this, till now we have colored node 1, node 2 and node 3 properly without sharing the common color for adjacent vertices. In the same way, if we continue, we have to go for the fourth node. In the fourth node, if it is red, yellow, red, then I can't, after red either I can't for see. Now for the fourth node, it should be different from third node and first node. So like this we got here different colorings. So now but here among these possibilities we can find some possibility, some cases where we are not getting the correct solution. For example, if I take this case where I have given the cross mark, see now here node 1 is red, node 2 adjacent to that I have used yellow, third node is adjacent to yellow, so I have used here green. Now fourth node is adjacent to third and first node, here we have used same red color, so this is not possible. Similarly, if I go for this again, this red, green, yellow, red is not possible. Like this total here I will get some 6 cases which are not coloring properly. So this we can check again here. So this is the complete state space tree we have drawn, which shows how the graph coloring is done by maintaining the condition. So now here I can show the example. So the possibilities red, see now here out of these 24 possible ways, 6 ways are not satisfying our condition, so these are the wrong choices, and remaining 18 possible ways to color a graph with 4 nodes using 3 different colors. So now among these 18 ways we can check that no adjacent vertex is having the same color. So now here maximum of 3 colors are used for coloring the 4 vertices. Either you can use 2 colors or 3 colors, but maximum 3 colors we can use, and we have colored. Okay, if you have any doubts in graph coloring concepts, so please send your queries either to my link, website link or to YouTube link. Thank you.